Big old giant flare. Hey, this is Coffee Compiler Club. We're here to talk about compilers and language runtimes and, garbage collection and typing systems and nil and not the nil and performance and security and anything else that makes sense with the language implementations. And open mic, ask what you want. Reserved right to moderate, pretty much never had to do it. You're being recorded. Recording show up on YouTube in a couple hours. That's it. That's my spiel. I'll do a little bit of start for AA updates, and then we have a new person, and we'll let him ask what he wants or say what he wants here. So AA, I've been busy traveling and got sicker than a dog, so no COVID, been checked twice. Saw my 2-year-old in Philadelphia. Cutest thing ever. I spent all week playing with a 2-year-old on the floor with a runny nose. And so, I always called kids at that age flu bags for a reason. And sure enough, I got whatever she had. Been recovering. So I'm busy doing AA with overload resolution, which is getting more interesting. I'm getting bigger and more complicated test cases that bring up more interesting situations. But I think it's coming into a conclusion, and I'll have well-typed, well-thought-out overloads, probably with nothing spectacular in terms of ultimate performance. Like there's going to be some test cases that's going to cause it to get ugly in terms of size and volume, I'm pretty sure, and I haven't gotten a test case in hand, but it seems likely. On the other hand, it will make doing the damn numeric overloads that everyone else on the planet has to deal with, which is the whole, what do you do with ints and floats on a strongly typed language? Some people have a custom type class things, and some people have just hacks in their typing system to support this. And some people just got explicit at every step, which was a pain in the neck. And if you're a C or Java guy, you just love the auto widening operations. And why the hell can't the language guys, the strongly typed language guys do that too? So that's where I'm at with that piece. We have a new person, Jackal. Did I say that right?
Yeah. Hi, Cliff. Big fan.
Want to do 30 seconds of what you're doing in life and why you're here?
Oh, sure. So, I'm based in Beijing now, and
what time is it there now?
Oh my God, it's 1 a.m.
Yeah, sorry.
So yeah, I just took a nap, and speaking myself, my daytime is like a deep learning compiler developer, and my night job is working on a Elixir and MLIR based on framework or toolkit to kind of like use very high level features in Elixir, like macros and functional actor, is kind of high level stuff to do like code gen in MLIR and finally LLVM. Oh yeah, that's basically about me.
Elixir, you have a link for Elixir? Somebody can drag up a link. I've heard the name enough, and now I can't find.
Oh, I think Elixir. Oh, hold on.
That's the Erlang that thinks it's Ruby, right?
Yeah, that's
here it is. All right, I have at least a bare minimum of a link. I'll throw in the link section here. There it is. Yeah, somebody got there first.
Yeah.
Yep. It's using Erlang. Okay. And God only knows what it's doing. And it's doing fault tolerant Erlang-y things. That's reasonable. And functional programming. Is it doing strong typing?
Yeah, the type is strong, but dynamic.
Dynamic. I'm sorry, static typing. That's what I was trying to ask. Okay, fine. Yeah, cool. Well, welcome aboard.
Thank you.
If you wanted to ask something right now is a good time, or if somebody wants to comment on Elixir.
Oh,
You mentioned
sure.
you were doing it.
Oh, okay.
Well, no, Jack will go first.
I was thinking, maybe as about this. I mean, so when developing like a compiler of this kind of stuff, so when is the time like you really need to like doing things in a more tidy or more clear way? Because now I think I'm just like hooking a lot of different not like the low level thing is in Zig, and high level thing is in Elixir, and basically generating MLIR. So a lot of things it's kind of dirty. So like when like it just like kind of like in this situation that like it's never gonna end, and I could never publish or release it. So like, so can you give me some?
Yeah, probably
Yeah.
can. So I had kind of a couple rules of thumb that I went with for doing this kind of stuff.
Mm-hmm.
If you're the only person who's going to look at it, you just clean up what you find painful. And if it's not that painful, you ignore it and let it be dirty because no one else cares. If you're trying to get somebody else involved, you have to do some cleanup. If you use the same piece of code a few more times than once, so my rule of thumb is about 3 times, I start to think about it as a library and not as I've got it here and I got the same kind of thing going on over here and I made another version over there for doing that, but they're actually all kind of the same. Then I make it a library and I turn it into an API and I tidy it up. And the rule of 3 there is just, if you have something done once, there's no point in like making a perfect API for a done once thing, because the API implementation and the way that you do it, they're all tied together and it doesn't matter. There's no API there. And if you have it twice, it's kind of the same thing. Maybe you want to make it tidy and neat because you can, but a lot of these problems have very squirrely edges. They don't have a clean, tight interface. Like if I'm saying I'm doing a regular expression, everyone knows what it is. It's got a clean interface, and you take strings to matching, fine, done. That one needs an API. If you're trying to take something from Elixir and map it down to something into Zig to go to some intermediate language, you're going to have screwy things left and right. There's no point in trying to make something tidy that's just not going to be tidy until you start to get so many repetitions that you want to think about what it is you're doing that you're repeating over and over, and then now maybe an interface that has a cleaner API that you think about and you test at and you unit test at or whatever. So I use a rule of 3 for that one. If a second person comes and joins my project and they tell me my code is shit, they're correct. It is, but their code will be shit here too. So they'll come along and do something gross and I'll think it's gross, and we'll have to start negotiating what we'd like to do and how we approach the problem. And generally in the discovery process of 2 or more people arguing out what the project looks like and why it looks like it is, you come up with a better solution that everyone can agree on. And while there's not necessarily 3 individual uses of a problem, there are 3 heads who want to use the same problem. And now, or think about the same problem, now it needs an API again. So if there's multiple heads involved, you have to come to an agreement on what the hell this code is doing and why. And any one person will either find bugs that somebody else misses or claim this is hideously ugly and I can't handle it. And then it's time to do some negotiation about what we can all agree on and maybe core out a piece that's a common subset. And then I'll have my version that I use and you have your version. And suddenly you have the 3 versions, but it comes from 3 heads. So that's another count of 3 is sort of a rough estimate. Like if my code's ugly and I'm the main owner and you come in as number 2 and you add code a little bit now and then, I'm not going to change my ugly shit for you. But if I get a third person and you guys are all like piling in hard and doing real stuff, there comes a point where, okay, I'm going to start compromising my bad shit so I can tolerate your bad shit. So between us, we don't have too many ugly things that we can start to, make a nicer looking interface. So somewhere around 3, uses either in space in the code or in space in people's heads, it's time to clean up. So if you're just doing this project for yourself and you're having fun and you're making something cool, don't bother. If you're trying to get somebody else involved and you're succeeding, then pay attention to what they're looking at, and you and whoever can agree on how we're going to divvy the problem up so we don't step on each other's toes over coding and shit like that. You know, make it cleaner. But don't rush to clean up. And you're making something, you're building, and so you'll be constantly changing. So if you try to clean up something and then the next day you realize it's just all wrong and you have to throw it all away, it was all a waste of time.
More so if you don't know what we will require or will it work.
You don't know what you're doing and where you're going. So there's no point in cleaning it up for an API that's perfect and wrong next week.
Jacqueline, I wonder, is your motivation to clean things up, is it primarily that you're looking at your own code base and maybe getting lost, or it's difficult to follow for yourself? Or is your motivation primarily that you want to be able to publish something and involve other people, and you want to get it to a certain point? Because I think maybe the way that you address it will depend on what your motivation is.
Yeah, if I understand correctly, yes, it's like the kind of like social pressure. If you look at like everything, like real successful big libraries, let's say like PyTorch, like basically just like kind of work out of the box. So like if you are trying to complete even just a little bit overlap, you got to provide like equivalent or even better experience. So
that's a different piece. That says I have a public facing API. Not I'm trying to stitch together some piece between Elixir, Zig, and PyTorch to make a deep learning blah, blah, blah on the inside that I'll never explore. You're showing somebody else an interface. That's exactly a public facing interface. The internal ones you do yourself or your dev team uses yourself, that's my rule of threes. An external facing one, no, I'm with you on that one. The hard thing you have for this external facing ones is that the good ones get good because of so many users and so many screw ups that you can, after 1,000 people use it, you have a different API that you want. So if one guy uses it, this is my rule of threes on internal, no one fucking cares because no one's looking at it. If 10 people use it, you get one kind of API and it can be kind of ugly. If 100 people use it, you want to throw away a lot of the ratty edges and limit yourself to being very tight and make end users do their own hairballs, and you don't want to be doing that hairball, whatever. Everyone has a feature they want. 1,000 people use it, oh, you got to be super clean, right? So the API, if your end goal is to have the API that 1,000 people will use, you have a hard problem, because the super clean interface doesn't have all the features and bells and whistles. It should not, but also it won't do everything perfectly well on the inside, and you won't have the right sets of API features because you don't have the users to tell you what's right and what's wrong. So you kind of have to step it through with some initial users to get somebody going, to know that you have some kind of a market traction saying that this is a useful thing. And then go back to the small count of users and say, okay, we have to make changes to make this expand to more people than just you 10. And the 10 people will know that that's coming anyhow, and they'll be willing to change. And now you cleaned up and you get to where it could be tolerable that you could get 100 people to use it. And again, you have to lather, rinse, repeat, and gradually change your API to get a tighter and tighter thing. And at some point you can't change anymore, and you lock down, you only add new features. And then you get the thing that looks like C++ or Java, where you have a million billion interfaces. Java's done a really good job of it, but to get that scale out, scale up solution is a long, slow process where you have to go kind of in orders of magnitude when you think about the public facing API. And that's just very different than your internal, the criteria you use internally.
Yeah, that will become like a social problem, kind of like, not just technical problem.
Richard Hipp has some good talks about the history of SQLite, where he's like, I thought I had a good API when I was using it for all my things. And then all my coworkers started using it and I had to fix a bunch of stuff. And then people outside the company started using it. And I realized, oh, at 1,000 people, there was a lot more that I needed to do. And then the aerospace industry adopted it. And he was like, oh my goodness, there's all these aerospace standards. And then he's like, okay, now I've got the thing totally solid. Nothing can go wrong. I'm testing every branch and every which way it goes. And I meet all these aero industry standards. And then it got baked into Android and got an additional billion users. And there were new use cases that essentially never happened until you had a billion devices that were all running it at the same time. It talks about the fact that SQLite really had to grow up as it got adopted by himself and then his colleagues and then his outside people he was working with and then the aerospace industry and then every device on the planet.
Every order of magnitude requires sort of a different level of thinking. So don't reach for the billion users solution. Get your 10, get them happy, then look to see why you're not getting 100 and start making the changes to get to 100.
And be okay with it if the first delivery that you have is kind of sloppy, right? Don't over perfect that until you get the 10 users happy.
I got too much time spent on my typing system and not on my delivery yet. So I'm feeling that pain right now.
It will pay out in the end.
Cliff,
I
may
hope
I
so.
share my
Yeah.
screen? I want you guys to have a little bit of look at.
Just a second. Try it now.
Yeah. So like this is like a Jupyter notebook environment in Elixir. So like, my project name is Beaver, and what it does is like using like this Elixir like very declarative syntaxes to like generate MLIR like yeah, basically you're generating MLIR here, and that's the MLIR generated. And you can like use these like functional like pipes to do like LLVM and MLIR passes. So you got lower to LLVM. Yeah, basically it's compiled. Yeah, I hook up some JIT to run it. Yeah, it's running. So that's the idea of this project. So basically like now you can do like pretty complicated things. It's like there are like, yeah, you can like orchestrate very complex MLIR and LLVM passes like this, and doing like
So are you're helping users sort of power steering, pick out which MLR passes to do? Or are you doing them all yourself? Like here's convert parallel loops to GPUs on line 26. Is that something that you are expecting a user to write, or is that something you're writing?
Oh, this is something like, sorry, I should explain it. It's just like you can write passes in like Beaver, my project. Let me give you an example. So like that's a small example. Like you can write pass to transform the IR and run it on the IR to transform the IR. And also you could like these passes are most of them are provided in the stock MLIR upstream, like in the LLVM.
Right. Okay.
Yeah. So like, yeah, does this answer your question?
Sort of. It just brings it more. So like you're trying to help somebody write an optimizer to convert code to run on whatever GPUs or I mean, I thought Elixir was running on Erlang, which is its own runtime.
Yeah.
And very little to do with GPUs.
Yeah,
Right. But
yeah, but there's some like efforts to like this project is called Index. Yeah, I contribute a little bit for that. It just the basic idea is that it's kind of like a PyTorch or JAX project. So you could like write this kind of code. Yeah, like kind of like PyTorch, but it's running on Erlang, but like it has some backends targeted TensorFlow or PyTorch, so that it could be accelerated by GPU as well. So like my project is like kind of like the it's actually two pieces now. One is Beaver, another piece is like for NX backend, so that like I can compile those NX expressions to MLIR and get it run on targets LLVM supports. Yeah, it's kind of confusing. Yeah, sorry, but
yeah, no, that's all right. I'm just trying to pick out what I see. There's a lot of things going on here. That's for sure. There's some big effort passes, and it looked very LLVM-ish.
yeah, you got a point. Everything related.
What's your high level goal here? To run
my yeah. So my high level goal is that like I know like everyone here have tried or I would use MLIR in your work. Anybody here?
Oh,
so
people do things with LLVM here a fair amount.
Yeah. So like this MLIR thing is like new work by Chris Leonard and the whole LLVM team. So basically it's like a generic representation of like a graph. It could be any graph essentially, not so that like we can use some like common like compiler techniques to generate code and optimize the graph, so that it could be compile and lower to machine code. And what I found like the problem about MLIR is that like it's very powerful and ambitious, but to use that, you need a lot of like I don't know, you need to learn how to like build LLVM, like no CMake, and you need to know like some LLVM specific tools, like then one is like file checks, this kind of stuff, and you need to know like how to write table gen.
We had this conversation 2 weeks ago about the learning curve to understand LLVM.
Yeah, I saw that one.
Yeah, we all agreed it was pretty stiff.
Yeah, so what I want to like shape is kind of like this kind of experience, right? It's very clear, in my opinion. You know how to generate some MLIR, and you can write passes to transform the IR. And as long as you could find a path to lower that to LLVM, you can run it like that, no matter it's GPU or CPU. So like that's this project is about. It's just and also like because
about
like
writing passes on MLIR that you're going to turn into go through LLVM to make whatever.
Yeah. So
is your goal to do this ahead of time, or that I have some running system that's on the Erlang VM, and then I say, okay, now compile this module and execute it?
So then we put it this way, just like the JIT here is just like a for experiment. For instance, like if you can turn this like LVM thing, if you like call the correct or proper LVM infrastructure, you could generate a shell library. You can generate a executable, but not necessarily like a fixed or a specific target is required. Does it make sense?
Well,
It just like
asking,
you don't need to have a like CUDA GPU to generate CUDA code, although like probably you can run it, but you can still generate CUDA code for that.
I think the question was, is it your end goal? Is it you're expecting people to compile ahead of time? Or are you expecting people to run Erlang VM, and as part of running, they're generating passes?
I think my end goal is like people could do both. If I had to give a quick answer.
Well, so if I'm doing a deep learning thing and I'm searching a hyperspace of parameters for a neural net, you can imagine that I keep reshuffling how I'm computing the neural net inputs or some of the layer pieces or whatever, and that periodically I want to rejit code for the next version of the neural net inner loop kind of thing. And that would all be something that you would do at runtime, or you might call LLVM, you know, every 30 seconds or every 5 minutes on a tight small kernel, and have, you know, replace the neural net inner kernel. I don't know, I'm just throwing out ideas.
Yeah, I agree. Like in this scenario, maybe most of the things will be run on the Beam Erlang virtual machine, and like it also possible you could explore these like kernels so that it could be run on things like a mobile phone, like a Android device supports Vulkan.
Sorry, Cameron and I are swapping funny texts.
Yes, yeah. I guess that's I don't know. Surprisingly, naturally comes to my second question. Is just that I don't really know what this project is for who.
It's for you. If you don't got a ready client in hand, it's probably for you.
Right. So ask Cliff what AA is for.
Exactly.
It's for him.
Someday, if it's running and working, I might find somebody who's excited to use it.
Oh,
Right
we
now,
will.
it's for me.
Yeah. I guess like I should yield my time.
Yeah, fine. All right. We are gonna, there you go. Let's say unshare, fine. Well, certainly good luck with that. And you've done the hard work of understanding LLVM's IR and some other pieces as well. You got a bunch of stuff floating around there.
Yeah, just like I learned a lot about like LLVM, MLIR, and Erlang itself. It's really a good experience there. Like, if you are really trying to build something like really a little bit complicated, and rather than like just using a programming language very superficially, yeah, I learned a lot. Even though like this project might go nowhere, but I still think it's worth it totally.
Absolutely. All right, hang on. You are okay. You are muted. You're not muted now.
Okay.
Say something.
This better?
Yes.
It's the same setting I had it on before. Like I don't know. One of those days where I guess I can join without crashing, but my microphone doesn't get picked up for some reason.
Kind of say that was a step up. I don't know.
I don't know. I did the same thing as did before, and now it works. So I don't know. Anyway, I was trying to say I looked at MLIR MLIR, whatever you pronounce it, a while back as a potential backend for my compiler. Not for now, because now I'm still using the interpreter, but I kind of decided in the future I want to move to ahead of time compilation. But my issue with MLIR was that there's just very little sort of practical info on it. It was just like, oh, hey, it's this project to provide this sort of generic IR, and here's a bunch of languages that use it. I'm like, great, but how do I use it? It's like, where do you even begin? So I think for that, this project could be quite interesting. I think for me, eventually, what sort of, besides that turned me off, is that from what I gather, you basically have to use the whole LLVM stack for it.
Ooh.
In a sense, it's not a...
The Google Docs has a link to the thing, which has a tutorial.
Well, I think if you want to use it as a backend, yeah, it's kind of, I don't know why you would need MLIR, because probably you just want to have LLVM, because MLIR itself, it doesn't have a backend. It's just a generic way to come up with different representations. And it has a representation like similar to LLVM-IR and lowering to LLVM-IR.
To my knowledge, yeah, go ahead, sir.
It would make sense, like if you wanted to have some higher level representation on top of LLVM and like do some transforms on this higher level of representation, then yeah, you would convert to MLIR, yeah, then lower to LLVM. But if it's just a backend, I think you just need LLVM or like something else.
To my knowledge, MLIR is higher level than LLVM, targeted to simplify some transformation.
Oh yeah, I guess I might provide some information here. Is that I would say the rule of thumbs is that like if you're what you're trying to compile is only like that like scalars, like integer floats, these kind of stuff, vector max, maybe all you need is LLVM, I guess. But if what you're trying to compile is like let's say tensors and some sparse like computation and like polyhedral loops, this kind of stuff, like there are IRs, it's called dialects in MLIR, like shipped with stock MLIR there. So you could reuse this higher level representation about these more complicated no matter data structures or instructions. So it will save you a lot of time and work.
Yeah, so for me, it was really, it wasn't so much like I necessarily wanted to compile to it and then to LLVM and then to whatever. It was more like I was trying to design an IR for my
They
compiler.
learn a lot from the mistakes. Yeah, so like PASIS is running in parallel, multi-threaded in MLIR. Instead, in LLVM, it's single-threaded. So this kind of little stuff like user experience, if there's any, in my opinion, it's better than LLVM. Like I used to like read the LLVM tutorial many times, and I never get to use it. But with MLIR, I meant to kind of have a little bit grasp, I guess. So I speaking like a couple of weeks ago when you guys talking about like the learning curve of LLVM, I would recommend like MLIR is like the learning curve is not that steep, I guess.
So, Yorick, you were saying? And again, we can't hear you.
I lost York.
He'll reconnect probably.
Yeah, fine. Every now and then it works great for him, and half the time, whatever he's doing. Crash and burn.
Okay,
It's good
so-
that we're all technical people.
Somebody was going to say something there just a second ago, because otherwise I was just reading about tensors versus
Mm,
anything else. Yeah, York. Oh,
Does it work?
yeah.
yes, you're back.
I literally all I did was I closed the settings panel of the Zoom audio settings. I guess the trick is I have to keep that open now, and then
Mm.
Zoom froze and then it unfroze. I don't know, computers, I hate them.
Are you using Linux?
Yeah, I'm using it through the Flatpak. I don't know, Zoom Linux is a bit of a mess.
I mean, there's your
I
problem. You should
like
be
the
using
browser
Linux.
version works reliably, but there's this thing where Firefox, for whatever reason, doesn't quite detect the aspect ratio of my camera properly. So like I look like squished.
Mhm.
Apparently an old bug. But anyway, what I was trying to say before the microphone stopped working, I was looking more at MLIR as a sort of source of inspiration for an IR, and less about, you know, I want to actually compile to it. That sort of came later. I took a quick look at the docs now. Yeah, they do now seem to actually have a tutorial. So it seems some things have improved there. But I think when I last looked at it, I don't know, maybe a year ago or something, there's just very little on it.
Yeah.
I think for me, eventually, I kind of decided against using LLVM in the first place, because it brings a lot of sort of maintenance problems with it. I think the biggest issue there being that the project's quite complex, but they don't follow semantic versioning and do have quite a tendency to break things between releases. And that combined with like every Linux distribution shipping like 2 different versions of LLVM,
Oh,
it
really?
means that if you they ship one, but everyone ships a different version. But so if you depend on, let's say, I don't know, LLVM 10, I don't know, the latest versions, I think it's like 15 or something. You're gonna run into problems where, like, you know, Ubuntu has version 10, but Debian has only version 8, and version 8 doesn't have these APIs that you're using. So they were added in version 9. And then you end up basically having to ship LLVM yourself, compile it yourself.
That's true.
As far as I know, basically every LLVM-based language does. I just don't want to deal with that. So in my case, my language for now is still interpreted, but I looked into potentially compiling to C or just straight to machine code myself. I'm currently leaning towards the second one, just because in spite of it being more difficult, I suspect I will shoot myself in the foot less than when I compile to C. Because even in C, like simple integer addition with signed integers has undefined behavior. So that's like the most basic thing you can do. That's where it already starts.
So is that going to like actually bite you? I mean, it's undefined technically by the standard. We all know what any.
I mean, obviously, I know. So I currently have a VM. I know the behavior I want, and I know how to replicate
As
that.
long as you want 2's complement overflow, you're good.
Right. But so things I don't want overflow. I want it to like panic upon overflow. But point being, it's I think we see this. There are benefits, obviously, like better platform support and all that stuff. And the fact, if you generate C, you don't have to generate different code for x68, 64, ARM, 64, etc. But you do have to deal with all the stuff with C. So the idea I had in mind was basically for my language to sort of keep my runtime written in Rust, and then instead of compiling to bytecode, compile to machine code, which then interacts with that runtime. That way, most of the scary stuff can still be written in Rust. And originally, the idea was to then, instead of machine code, compile to C.
Wait. You're doing the scary stuff in Rust, but you're putting what I guess would be not scary stuff in machine code.
So the idea is basically, I now have a VM, and I have bytecode that is interpreted. The sort of problem with VMs is that they can only go so fast, and at that point, you either accept it or you write a JIT.
Right.
Now, I don't want to write a JIT for many different reasons, but
Right.
the most important one being I don't think I comfortably can do that and make it competitive.
C or Rust or MLIR or LLVM or whatever.
Yeah. Right. So my idea is, instead of compiling to bytecode, the code of my language would be compiled to, C or machine code or something else. But I don't want to rewrite all the Rust code I have in either my own language and make it all self-hosting, which in particular would mean I would have to expose certain functionality to the language, which I don't want there, like shared memory. My language doesn't have it. Atomic's language doesn't have it, and I don't want to introduce it. So the idea I had in mind originally was I will sort of change my VM into a runtime library. And for the most part, this is doable because there's a clear API. Like each instruction, you would sort of make some sort of function. And it's already kind of structured as a library because my command line interface sort of imports it as a library. And then whatever code I would generate would essentially statically link to that runtime library.
Okay, hang on. You have an interpreted system. You have a theory that says you want to go execute bytecodes compiled. Are you going to compile everything, or are you going to have some things compiled and some things interpreted still?
No. So it will be fully compiled. I think the
So basically, you do ahead of time compilation, and you have your Rust runtime you're going to call into.
So I think a good example there is Go. Like if you take your Go source code, you compile it to a native executable, but it still has a runtime. Now, in case of Go, that runtime is written in Go itself.
Yeah.
I think way back it used to be written in C, but then at some point it became self-hosting. So the idea I had there was that runtime in my case would be written in Rust.
Mhm.
And the theory at the time was if you can compile to C, what you can do is you can take your runtime, compile that as a static library, statically link it to your generated machine code, C code, sorry, and then use link time optimization to optimize it more, and in particular get rid of any sort of function calls that you might need in case it were a dynamic library. And Rust supports this. It has this feature where you can sort of cross-language, so you do cross-language link time optimization, provided it is all compiled with LLVM. So the idea being is you compile your Rust to LLVM IR, and then you have, say, some big C project, and you compile it, and it essentially all compiles and optimizes it as if it were all written in the same language.
Yeah.
And that sounded very compelling on paper, because I would write my runtime in Rust, compile to IR, and then spit out C instead of bytecode and compile it all together. Unfortunately, 2 evenings quickly revealed that this is very far from practical, in a sense that I had a laptop and a desktop. I initially didn't get it to work on my laptop, as in it would run, it would compile, but it wouldn't optimize away the function calls. I had some simple, like was just using a simple integer addition through a function. I eventually got that to work using a bunch of options that I don't remember. Then I tried it on my desktop, and there it crashed. Then it also crashed in some dependencies. I had to do some other stuff there to get that to work. And since then, I've not been able to reproduce it. Like it will run, it will work, but it will always go through function calls. And also from the docs, it basically seems you have to use like a very specific set of versions, and they all have to line up, and like the planets have to be aligned, and then it will work. And crucially, you have to use Clang in practice for your C code. You can't use GCC. And that kind of defeated the purpose of compiling to C, because then if you're always going to use one compiler, you don't get the portability of some weird compiler for some embedded device.
Yeah.
And so my current thinking is still keep the runtime in Rust, but use that for the sort of more expensive things like scheduling tasks to run IO, things where basically overhead of a function call doesn't matter. And then for the sort of the guts, like integer addition, all that stuff, that will go through machine code. But I'm not sure yet, because
Chris, you'd have to
it-
lose
it-
his Rust. See, Chris put a comment in the chat that I think is pretty
Well, to be
close.
honest, that would be really funny to well, basically compile Rust to Java bytecode. That would be awesome.
So I did consider actually compiling my language to Rust, because then you get the benefits of everything the Rust compiler has to offer. But it felt a bit redundant because my language already does certain analysis that Rust also does. And so Rust basically ends up wasting its time. But also the Rust compiler is just quite slow, to a point where like a hello world will take, I think it's like a second or something. And that's not a big deal, 1 second, but it's like the most basic program already.
Yes.
And that was actually another problem with this link time optimization trick that I thought would work, is the runtime you would compile ahead of time just once, and that would take about 30 seconds. For comparison, normally it takes like 10. So that's already slower, but that's a one-time thing. You do that, I don't know, when you install the language. But then the problem was that even a simple hello world that would link time optimize against that library would take 5 seconds. And that was the most basic thing. I was like, oh God, imagine what it's going to take for like a larger program.
So I used Java Assist to compile Java to Java bytecodes and H2O because I generated serialized and deserialized code using unsafe peek and poke fields. So I did direct NIO buffers into Java objects where I had both sides negotiated what the protocol looked like, which was custom for every data structure and every cloud that came up of a bunch of guys. So the structures got laid out differently. Fine. The two guys handshaked and whatever. Everyone in the cluster handshaked. We all agreed this is the protocol we're using for your structure today, right here, now, only here. And we all JITted code for it. And the code was Java code that you could read, that you could fucking debug it. And then Java Sys turns it into bytecodes, and then the JIT turns it into machine code, and it inlines across all boundaries, and it works great. So not claiming you should go there, but it is the case that you can do it in Java, and it's pretty damn quick, and you get good code.
Yep.
But you have everything in Rust, so you'd have to go from Rust to Java, and that's a big pile.
Yeah, and so for now, this is just an idea. Like, I don't expect to be doing this at least for another year, because I am actually reaching a point where I can soon publish another release, and I don't want to go off another path for like 3 months and then find out it's not going to work or something. But it's something it's more something I'm working towards in terms of simplifying the language implementation, trying to get rid of things that would potentially get in the way of that. And just things I generally don't need, so that if I reach that point, it's sort of very clear, like, okay, these bits and pieces will be provided by the runtime that stays there. These bits and pieces I can generate, machine code, and then you just sort of glue it together from there.
I worked with this database startup a year and a half ago or something, and they were doing Julia, which used LLVM as the back end, but they were jitting code, and the jitted code from LLVM was very slow to get code, and he did nothing that crossed the borders between two pieces of LLVM jitted code. So everyone did a horrible indirect handleized function call. And I know Arthur's been working on doing the proper setup for an LLVM call, where he brings in like profiling data and enough other stuff you can cross the inline boundaries and shit like that. But I know also that's been like a decade of work. I don't know, a decade. It's been a lot of work for a long time.
Yeah, you can make it work. It's just it takes effort.
Yeah, how long have you been working on that project, the Falcon?
I think it started in 2013. I joined 2015, and I think we released the first version in 17. So it's 5 years since the first release, and like 4 more years before that.
Yeah. And how many people?
So it's the initial team was of 5 people. Right now we have 12.
Okay, so 5 times 5 years is 25 man years, and 12 times 4 years is 48 more. we're pushing 75 man years.
Yep.
All
It
right.
sounds like a hard problem.
Yeah, that's what I'm thinking. No, it's all good, but I'm not piling in on that pile, that's for sure.
There is a question for you, Cliff, in the chat.
Oh yeah. So mostly what I would like to do with AA and Rust is I like Rust's concept of borrow checking, and I'm doing type inferencing in AA. So I think I could do something with AA where I would infer in a type language the borrow checks sort of in all interesting ways. But I don't know this because I haven't implemented. So what it really comes down to is I've done a ton of extensions to static typing that I don't see anywhere else floating around in the community. And so I'm kind of like thinking there's more that I can do here if I want to get off the typing bandwagon. I mean, I want to stay on the typing bandwagon even longer. So at some point I'm going to be done. Like overloads are the last thing. I said this about something else, 3 months ago, but overloads are the last thing I think I need to go do sort of the easy core AA where I'm not actually doing borrow checking yet. Then there comes a point where I'm going to say, what are the extensions I want to let people write in the type system directly? Borrow checking looks like one I would like to be able to write in the type checker directly. There's a couple other things that I end up doing all the time that I would love to have compiler support or typing language type support for. That I think I could extend the typing system support. So at the moment, no, I don't have a Rust check, a borrow checker. I think I can do something exciting in the type system with the borrow checker, and I haven't tried it yet.
Oh, speaking of typing, I kind of want to ask you, like, are you doing these kind of Rust C++, like these turbofish, like generic thing, or is this more structural, like Elm or Zig?
It's
If
more
you got my point, just like
maybe I'm not don't have turbofish typing on the top of my head. Strong static typing like you get out of Elm or Haskell, and also strong typing I get out of what I call forward flow typing systems like you get out of C++. Rust term for generics. Then yeah, it's static typing from the Elm style or the Haskell style. So I get what people write down there. I totally can do that. Now I'm doing 100% type inference. You can add annotations, but you don't need to. And so I can kind of shockingly, strongly well-typed things that would have generics. I'll just statically type them and give you the type for them like you wrote it as a foo of an int, except I'll tell you it's a foo of an int. You don't have to say foo or int. And then if you want to add an annotation, I'll just confirm that the annotation you wrote actually passes. Like I'll give you a most generic type that's strong everywhere. It has whatever the right term for it is. The most principal type. That's the principal type. That's the word I'm looking for.
So my question is more like more specific. Is like, let's say like you have a struct of fields A, B, C, and you have another struct of fields only A and B.
Yeah.
So like in AA, like is it possible to write a function like handle like a fields with only A fields and B fields, but you can also pass the structs actually with C field?
Yes, it totally is. I'm looking to see if I had an easy example.
Oh
right
yeah,
in front of my
so,
face.
yeah, that's the structural thing I'm talking about. It's like Elm and Zig.
It's structural. Yes, it's structural typing, strong structural typing. There's more things going on that I do above and beyond what Elm and Haskell do. Here we go. So this is probably not necessarily a great one, but maybe it's show you. No, here we go. This is better. This is a tighter one. Tighter vehicle. Okay, so let me go find the Google Docs. Go find code block. Here is a non-indented piece of code. It came out of a test case, so I'm busy going to indent it. And this is not AA syntax. This is a core lambda calculus that AA is using to do its the lambda calculus that AA is using to type things. So this is a simple map call.
Can you share the screen?
Oh yeah, there you go. I can. That's a good plan. Let me go find things again. I'm just sharing the Google Docs, but that would totally make sense. And we picked up Simon, and I wonder how long he's been waiting. Gosh darn it. Okay. Go back to, here we go. Yeah. So what I did here was, well, let me throw the type up as well so people can look at the types. And this is, and the type I'm going to show here is type I'm totally inferring without any further effort. Maybe I'll put it down below here. And I will re-indent the type as well, so it might be a little easier to read. Okay. Yeah, I'll do one more indent here. So the program is just a map, it takes a function and a list. So I'm going to highlight function, map, list. Okay, it takes a function and a list. If the function is not null, do something exciting. If it's null, return a null, and it's the end of the list, right? And then what is the type of map? Map is a function that takes a list. Okay, what's the list type? Well, if the list is present, then I'm going to build as a return a structure. So this will be the at open curly's return a structure, which consists of a field in1 and v1, where the in1 field is defined by map on function of list, which has an in0 field. And the value one is a function applied to the list of the value 0 field. So it's a classic map over linked list where it takes in a structure which has an in0 for a next and a value 0 for the payload and produces a new list which has the function applied to the values in every element. And the type I infer is function is a type from A to B, and the list is typed as a pointer to a struct which has a next field which is its own type, and a v field, a value field which is of type A, and some extra fields. The ... is extra fields. Returns you a structure where the in1 field is a D, it's a self-recursive type, and the value is B, which is what you got by applying the function to A, you get a B back. And it doesn't have any extra fields because I didn't add any extra fields in the map call. I didn't carry any extra fields over. So the typing here is, I'll take any linked list looking thing has a next, has a value, and extra fields, which I'll ignore. And I'll produce you a linked list, which has, you know, the function applied. So that's core AA lambda calculus style typing. The core AA syntax is a little bit more straightforward for things like the if statements and shit like that. So does that answer your question? Because you said I had some extra fields and I had some common fields and I used the common fields for multiple guys. And the answer is yes, I totally do that.
Oh, that's cool. Yeah, that perfectly answered my question.
Yeah, okay. So I have like, 100 or 200 of these sort of point tests that tickle hard aspects of things and validate that I get the correct answer out. And this was just sort of an obvious linked list ones. I guess I probably have a tighter version if I find it where I do a question mark, colon, ternary operator to pick out this fields and that fields. Yeah, here's a test case. Let me go throw this one down as a little bit more excitement to it. Well, that didn't work well. Let me try pasting again. So this is the test case as written in Java with @test being, you know, JUnit. Run this code. So the code in here, there's some highlighting thing to be done. Didn't we turn on a highlighting extension? Code blocks, start. Boom, code blocks. Okay. Now, can I take this? Whoops. One more time. Hello, Google. Let go. Thank you. Oh, format it here. Language Python. Let's see here. I don't want Python formatting. What did we decide the good format for this was? We did it last week and had something that was reasonable. I don't care if let me just find like C or Java or something. How come I cannot find there? Okay, close enough. Yeah, it did weird things on me. Fine. So what I'm doing here is I say some predicate is 0, some struct1 has a field X, some struct2 has a field with Y. I randomly pick between the two, and then I pick out the Y field. So in Elm or Haskell, this would be a type error because struct1 doesn't have a Y field. And in fact, one of the errors I get here is there ain't no Y field, so you lose. If I turn on some of these other answers come about from me using more extensive typing, where I know at typing time that the predicate is 0. Because the predicate is 0, I know at typing time that struct1 is dead and will never be executed. Therefore, the type of this expression, this if expression, is only the type of struct2, which in fact has a Y field, which you can pull out and know it's a constant. So the typing has not evaluated this, it has typed it. The type is the constant floating point value 3.4. And that is an extension to Hindley-Milner where I do dead code elimination at typing time for obvious constants. And the goal of that one is actually to let you say, if def Windows, else if Darwin, else if OS X, else if Linux, and have broken code in the dead branches because you need different arguments for your calls to the OS for whatever things you do. And they would not be type correct on the other OSs, but they would be syntactically correct. So as long as it's syntactically correct in the AA, but AA also knows that the arm of the if is dead, he will happily tell you that I don't care that it's semantically incorrect. It's syntactically correct. I pass the parse error. I'll declare it a type error in dead code, and then I'll ignore the type error in dead code. So that's one of the extensions floating around AA.
That's exciting.
So if I
Sorry?
decide to store my constants in a constants file, and then I change that constants file and re-eval in the global space, do I run the risk that I'm going to cause some cascading recompile when I do that eval?
Well, whenever you do an eval, it has all the rights and privileges of whatever you had already. So if you have an eval in somewhere in the code, the runtime system has to decide if it's going to try to JIT a slow moving constant as an optimization, or he's going to just, declare.
Right, but it thought it was perfectly constant because there was
No.
literally nothing that assigned to it
No.
anywhere.
No,
Well-
as soon as you have an eval, anything can happen in that scope. So evals are scoped. And if you haven't got global constants available to the scope to the eval, they're constant and the eval can't change them.
So
Like, you said global constants and I loaded from a file. So somewhere in the world, I said, I have a mutable field. It starts initialized to 0. I read a file. I filled it in from the file. Now you have a high level pile of constants. Later on, you run an eval. If those constants are out of the scope of the eval, they're constant and it's done. If you pass them in as a data structure containing a pile of constants into the same scope as the eval, yeah, the eval can hack in, and the type system knows that, and they ain't constant no more. So the typer would say they're the type of the constant 3 or anything the eval does to them, which will give you, bottom pretty quick.
So my OS variable better be a real constant.
Yeah, things like that should be.
It can't just be something that never got changed anywhere.
Right,
So
and the easy way to do that is just use a final assignment.
Hmm.
So in this particular core AA lambda calculus language, I don't have mutable assignments at all. All assignments are finals. You can't go changing things anyhow. In AA, the default is to be final, but you can ask for immutable assignments. But if you ask for mutable assignments and you follow that up with some sort of call to an unknown function, which is what a val does, the assumption is it gets mutated. Therefore, you can't trust it.
Fair enough.
So if the typer correctly determines that predicate is always in constant, can figure it out and remove one branch, what would happen if the predicate can be mutated so that the typer result is no longer correct?
Well, it's not a constant then. So the
And
typer doesn't type it as a 0. It types it as a mutable,
So
whatever going to get
it
mutated.
would have to
Now,
unify.
In this particular, so let's pretend I have a syntax in the Lambda calculus that allows mutation, and I'll show you some test cases here just further down where you can see that you're setting yourself up for a problem that isn't a problem. So suppose I have this, except I use colon to say, oh, it's mutable, and I'll go ahead and break the lines up a little bit so it's a little easier to look at.
Yeah.
At the time I type this expression, if pred S1, pred is in fact 0. Because it's 0, it is correct, and I get a value out here. My result is happily, 3.4. Then you said, well, pred got mutated to true. Well, it's too late. Res has already typed as 3.4, and you mutated pred after the fact. So that had no effect. So instead, let's say that, oh, somewhere in here I had some unknown function, and he was going to mutate pred on me. Oh, that was really, why did he not do, here, let me go ask the Google later for him. Look at that. Why did he, wow, he's sometimes doing the ellipsis fold up on me and sometimes not, which I actually don't want it. Fine. So here, I'm going to say pred is unknown in the typing system because it's a mutable variable. I have an unknown function, pred's in scope. It could be that unknown whacks pred. If it's actually unknown, like the typer has no clue. Now, if the whole program is available, I'll look and see if pred gets whacked inside of that unknown call.
But the problem is eval.
If that's an eval, I'm going to assume it got whacked to trash.
But I agree with this, but the typer would have to determine what to do, how to type the code prior to execution and eval. It doesn't, this function doesn't know, will be there in eval later at some point. That would change the assumption of pred.
As soon as there's an eval in there, pred is unknown. As soon as pred is unknown, this expression
will have to unify.
It will not unify. It's type incorrect.
So we have to be careful with the mutable state from the typer. That be. Because eval can do anything you want. You can change variables post after the fact.
Immutable variables. It cannot change a immutable variable.
Yeah.
A final variable. But it can change mutable ones to anything you want. Yeah. So that's the distinction here. If there's no eval, it's a 0. The typer knows it. We're good. If it's unknown to you code, but it's locally present and available in the system at the time, the typer sees it and knows that it modified pred or it did not. Right. So however I got that code, if it came from a module, I'll have the summary type, which will tell me that pred is getting modified or not.
And that would, if it's I understand, if it's understood, if it's the predicate, the pred can be unknown, can not be figured out at compile time, the compiler wouldn't try to assume that it's just a Y branch. It just can call.
As soon as pred is unknown, the if test down below here, the if pred has to go both arms.
So the fact that pred is made mutable this way, the code wouldn't type check as if now.
This code does not type because eval or because pred is mutable. If you remove the eval or remove the mutability of pred, this code will type.
Yeah, that would be correct. Because after the fact, if you can change the pred, you have to somehow retype the expression if you change.
Yeah, I'm not right. I'm not retyping. The typing's all ahead of time, right? So
so
that's the static typing part of static typing.
So, That's correct to me.
Okay.
Okay, next
Any more
question.
AA examples you want to see?
Yeah, why not? If there isn't like more questions.
I'm sorry.
If there are not different questions, why not?
What else do I got here that looks like fun and crazy?
Mm.
Here's the, let me find the better nil check one. This is an ugly nil check one. But I don't know that it's like terribly exciting for people to look at. Parametric and nilness. So we go down to oops, there you go. There you go. Can't, geez, Google, quit that. Undo, fine. Maybe, yes, fine, okay. So actually, I guess this is more complicated than is necessary. Oh, wait, look at it. Tabs are screwed up. Quit that. Okay, let's see, try it without tabs. Get our alignment all messed up here. Yeah, tabs are screwed up. Die tabs, die. So what I was trying to do here is say function takes two arguments and just applies one to the other. It's a compositor or something. And in the first case, function is defined as takes a struct 0 and looks up the X field. And it's passed the struct, so it knows that it's valid to look up the X field in that struct. In the second case, so pair is just used to give me two answers out because I want to look at both tabs. Second case, I passed a struct 1 where I'm nil checking it. And if it's nil, I'm going to return a 4. If it's not nil, I'm going to look up X. Okay, and then what am I passing? I'm passing an if pred. Okay, I'm passing, so pred's an unknown to me. It's a random thing. Passing you a nil or an X. So if I don't nil check this, it could null pointer exception. And the trick here is that map takes a function and an X, and in this case, the argument to the function in one case is known to be not nil, and in fact, it's passed a not nil value, so that's type correct. In the second case, it's passed a nillable value, maybe nil, may not be nil. Oh, yes. All right, nice seeing you, Jekyll. I get the time zone issue. Good night.
Good night.
If this case, if it's passed, I have to know that I have to test for no. So this passes type checking, and the neighborly friend here, nearby neighbor in the code space friend, will fail the type check. So this version passes. And I have another version here who didn't do what I expected. Let's see here. Yes, had the same tab problem where I failed the nil check. And my answer is, the type you get for this is this type. Okay. So let me sort out. You guys can read it while I get rid of tab things that are happening to me here. A little bit of alignment was a little better looking. It's not quite aligned right. It's good enough. Okay, so what the second guy says, this was an error. I know the type of the first expression is take a not nil struct with an X field and look it up. It gets me a 3. So the end result is I take an unknown predicate, which might be nil. That's the question mark on the A. I return you a pair. That's the star open paren. Pointer to a pair, the tuple here, whatever. The first element's a 3. Typer knows first element's a 3. Typer knows the second element is an error, may be nil when loading field X. So map is polymorphic in nil checking.
So this would be an equivalent to an option of 3, maybe?
So there's no option put on the 3.
Hmm.
Right. This is the difference. I think this is the difference between option and nil. There's a couple differences between option and nil that I've been messing around with, and I have some test cases. I think this is one of them. But basically, I didn't claim that map took an option.
So you represent the uncertainty of the 3 or maybe nil of X.
I represent the uncertainty of whether the X is nillable or not in the type system directly. So the type of map is it's an A to a B, but if it's an A, then the A is not nil and passed in a not nil struct. You know, the type of function is it takes a not nil struct and has an X field, then you can pass in a not nil struct. And if the type of X, the type of function is if it takes a not nil struct and you pass it a nillable struct, you get a nil error.
So the first, the type of the first function would be A23, if I understood correctly.
The type of this
here in the first function.
up here.
Yeah. What
Type
would be the
of
result?
this is a function which takes a not nil struct with an X field and returns you that X field. So that type of function, funds type, is a not nil struct with an X field, star X equals some leaf, some type here A, and extra fields, and returns you to A. And the type of the second guy is a little different. Okay, I attempted to, why you're not, oh, okay, I'm not yet happy with this thing. Okay, the type of this guy is it's a nillable struct, and it returns you a 4, or this is actually, let me say, the type of this first struct is it's a X or 4, which is going to be an int. It's probably going to be an int, but it's something like this, because you're either going to get a whatever X has or a 4, and those have to unify.
And here you wrote the resulting expression of this. What would be the resulting expression of the whole? What would be the result of the first expression?
Okay. Yeah, here, yeah, fine. Oh, that guy, it'll be nint for the other guy. You'll see here. I'll just here. It's going to be so because you're mixing 4 and 5, so you get a non-zero integers. You know, it's nint 8. Core language doesn't do 8 versus 16 versus 64. So the core just says it does do not nil. So you get a nint, but it's nint 8.
Yeah, the shortest possible would fit 4 and 5.
Yeah.
Okay, that's correct. Maybe.
And mostly what I was saying, mostly what I get out of this is that I'm polymorphic in nil, as opposed to always requiring an option, which is how you would otherwise handle this thing. It's actually polymorphic in nil. Because it's a little different than nil. I mean, sorry, a little different than option directly. What else is exciting here? It's not eye charts here. You know, I got the piano arithmetic ones going just fine, but they're like an eye chart to stare at. They're like brutal.
One last question. Could be correct if this can be nil, would be nullable nil, something like this, or
no, you get rid of the n if it's going to be this is an error. So the guy you just were hacking this because it's an error. But if you could load a nil out of X, then instead of being a nint 8, would be an int 8. To make the nillable thing work, every ground term and every other term that builds from a ground term understands that it's nillable or not.
So in this case, would have to, it's a primitive and have to have default value or no?
Well, it's core AA. There are no default values. Everything's directly assigned.
Okay.
In AA, of course, it's like Java, default values of nil.
Okay.
Pretty straightforward.
Okay, I think I got it.
Okay, yeah.
Yeah.
What other exciting things that are like legit to look at here that are not like death on iChart time? No, it's not really special. That's mutual recursion things and more struct things, obvious games with, I can contain my errors. So I have bad argument counts to function calls, missing fields. Now there's like 5 or 8 errors that I can come out of the core language that all just turn into, that's interesting. I'm trying to look that up. Unify error, bad arg count. Those are propagation, ambiguous overloads. Where's missing fields? I haven't moved it into the missing field category here. There it is. Missing fields. Can I do it this way? Probably not. Maybe nil while loading. So maybe I only have like 5 errors here that I can find missing. Oh, that's parsing errors. Those don't count. You have to get past the parser for this game to kick in. Yeah, okay, it's a couple places missing field tips. So I think 4 or 5 errors I can find in the core language that I can then contain and represent. So nil check missing, field missing, wrong arg count on a lambda. And then the generic one is mixing 2 types that are unrelated, ints and functions. And you'll get a, cannot unify error. And these are all containable so that if the in type doesn't percolate up too far and then gets dead because it's not used, it doesn't end the type checking for the whole program. So I run type checking to the end. And after that, so the current hotness is me doing overloads, which are missing. The error situation is getting better on overloads. There's some funny cases I haven't decided I like or I don't like on overloads yet. And then I have some other examples I'm working on that overloads exposed to me, having to do with recursive function definitions, like I'm trying to do with the main AA's integer type representation will be as a wrapped int with 0 overhead. So it will still be an int in the hardware, a primitive int in the hardware, but will be typed as a wrapped int. But then I get a bunch of all primitives take a wrapped int, return a wrapped int, and compute on a wrapped int, which is fine, except I get a bunch of self-recursive calls, and then I'm getting some canonicalized versions out, and I'm sorting out what I'm doing wrong there. And I think I'm actually just writing the code wrong and not typing it wrong. I think the typer's correct on that one, and I'm writing my wrapped int primitives wrong. It's another, now it's getting into the realm of I don't have a short, quick, easy answer. So I can throw it up, but it's not obvious what it is it should be or should not be. So here I'm just making time in case somebody else wants to talk about something else. You're welcome to bring this up.
Mm-hmm. Yeah.
This is what I'm wrestling with the moment here. So this is a core AA representation of what might be a wrapped primitive. So fwrap is a function which takes a primitive float and wraps it.
What is the purpose of the wrapping?
The wrap is to let me, it's actually to let me get away from having to have custom otherwise code for widening. So I went through like Java and C widen ints and floats. And I've been wanting overloads for a while as a way to handle more generic polymorphism things, but they would handle this case as well. So this lets me get away from, at the cost of supporting overloads already, I don't have to handle any sort of special case scenarios for widening ints and floats or widening ints and booleans or ints and strings or whatever you want to do with those kind of games. Instead, what I'm saying is the wrapped guy has a bunch of functions that take other type arguments and will do the appropriate widening in there. So FF is a prim float. So field F holds a prim float. This is an operator multiply. And you could just replace it with the word mul, but it's an operator. When I do it in the main AA, I get rid of the leading and trailing underscores, and I know it's a infix operator. It's a binary infix operator.
Yeah.
And the underscores
So
tell me that it's a binary infix operator.
So it's not that an I8 can always turn into an I64 without being cast. It's that in a particular function, it allows you to do the upgrade.
Yeah, that's where, well, the I8s and I64s won't upgrade, but they'll type as one's a subtype of the other, so they'll just type. That's because I'm doing the mixed forward flow typing in Henley Milner, and I8 is just a subtype of 64, and it will just go. You can pass an I8 in for free. Wherever an I64 is called for, you can pass an I8 in.
Yeah.
So no further games have to be done there.
And those same rules apply for nullable. Anywhere I need a nullable string, I can pass a string.
That's correct. Yeah. No, if you pass, I'm sorry, anywhere that you take, yeah, that's works. You're right. Anywhere I take a nullable string, I can pass a string in. Yes, that's correct.
Yeah,
And
the opposite is not true. I can't pass a nullable string to something that needs a string.
Yes, right. That's what I was going to mess with here. I was going to finish this one out here. So here, y has a field y dot I, and I to F is int to float conversion. So and F stars so the names here. F star is you know the function float arrow floats, just float multiply, right? If you like this, it's typed as that, but that's not its execution. That's its type. I star is the obvious int. I to F is int float. I can just type here. Okay, fine. So so a float wrapper takes a primitive float and wraps it. And the wrap thing is a struct that has the float as a primitive field F and has a multiply operator, which is an overload. The overload has not been indented properly because of the evilness of tab expansion. Oh God, and undo is different between things. Get rid of why is this tab not going away? Thank you. Okay, that's probably a little better. So the multiply operator is an overload of two functions. So you pick one. One of the functions takes a float, just does a float multiply. One of the functions takes a wrapped int and does an int to float conversion and produces a float out. So this is my current straw man test case for what it means to be oh, here we go. Here's another indent problem for tabs. Some cut and pasty thing going on with, oops, yep, doing tab horrible things to me that is not correct, that I didn't ask for. I don't have tabs in my code, so I don't know what this is about.
So the f wrap is introduced, so you can mix a float and ints in this function.
Yeah. And int wrap takes the same thing.
The reverse.
Yeah, and you get an int multiply, or you get a float multiply, and you do f wrap or an I wrap.
So how would I write something like, I want to turn this integer into raw bytes?
Well, what's a raw bytes? That's an array of bytes. So that's
like there are cases where I might want to say something like, turn this float into the integer that the bit pattern represents and not the number that it represents.
Yeah. I'll have something in there. Like I've thrown one operator primitive in, but I can throw in dozens. So there is an operator primitive that says, given a float value, give me the equivalent bit conversion, raw double to int, or double to long and raw long to double.
I see.
That's same as you get out of Java or anyone else. I mean, whoever else will do these things. Here, because it's a wrapped guy, I can just call the function on it directly. So a use case here in core AA would look like 2.raw double to int, right? And it has a field raw double to int, which is a function that you call and it does the thing. That's the core, that's the main AA, not the core lambda calculus. Core lambda calculus, con2 here on this line I just highlighted, con2 is a wrapped 2, and 2.1 is a wrapped float 2.1, and here I've got a load a field out of the 2.1, right? And there's the dot for the load of field. So pull the multiply out of the constant 2.1, multiply by 2.1. I'm hoping to get an answer of 4.42 or whatever the hell the product is as a wrapped float. And the type I get back out is almost, but not quite what I want. And it's a little odd in a funny way because I can make a fake float. Let me show you where I'm headed with this example. And then the fake float works up to a point in types, and I get funny answers out of that. So fake float is a structure which has an F field with a primitive float and has an unrelated field that has nothing but nothing, bogon. And then I come along and I say, oh, con2.1, you're a floating guy. You have a multiply field. Can you take a fake float? The answer is he can take a fake float because all he wants out of the fake float is a 2.3 field, the F field, right? So he's all happy to take that, declare the overload, be pulling out the F wrap of the 2.3 and produce a result. And the type he gets back out has bogon in the type, and it should not have bogon in the type. The type you get back out is a structure which has a float value, which is what you want, and it has a multiply operator primitive who has a wrapper thing that takes a bogon field, and then that's incorrect. So I've blown something, and I'm busy. That's my current. I'm like, okay, what the hell is happening now?
But if he never looks at it, that's fine.
No, the end type should not have bogon in it because it's dead in this expression. The fake float goes up to, so you follow the math here. You go to 2.1, which is this F wrapped dude. You go up to an F wrap expression, you look at the underscore, you get an operator overload. Okay, you're gonna pick that float overload out of it clearly. Okay, you pull a float over out of it. He takes a bogon for Y, takes a fake float for Y. Y becomes a fake float. Let me highlight the line here. So I started with con2.1, which I know is an F wrap because it's this structure. That's what I get out of F wrap. I look up the underscore field. Okay, I get an overload. I look up this function. Okay, in this function, I pass fake float in for Y. Inside of this function, I take fake float. I pull out the F field. I then call F wrap on the result. F wrap says I computed the math of 2.1 times 2.3 and got 4.56, what the hell I got. And I do an F wrap. What's an F wrap? Well, an F wrap has a float is equal to a 4.56 and an underscore of an overload of blah, blah, blah. No bogon, because bogon wasn't ever used when you called F wrap. I called F wrap here. I told the Y field, Y.F field out of the fake float. Never again was the fake float used to compute the F wrap anything.
At this point, the float should have been selected from the structure. And
yeah, should have pulled the float right. And then bogon is never selected. So F wrap should not produce me a struct that has a fake bogon in the type. And it does right now. So I've got something wrong somewhere.
Does it returns the structure or?
Yeah, okay, hang on. So I'm giving pieces, parts from multiple examples because I'm busy stitching examples together.
Yeah.
I have a slightly simplified version, but it's actually pretty close to this. It's not too far off. So let me let me pull out the current type here, which, like I said, I believe to be incorrect. And I have shortcutted a bunch of other things. Where did this one go? That's the type I want, damn it. I'm sorry. I'm stuck. All right, hang on. I have it in the debugger. I wrote in my test case the type I want. Here's what I'm getting out of the debugger. Oh, goddamn, he's trying to hide the top guy here. This, I can cut and paste from here. Okay, now I have what I want. Come back to the Google Docs. Here we go. This was what I want. This is what I got. So that percent you can ignore. That says I know it's a copied value from the original constructor. It's fine. So the end type is a structure which has a float, has a multiply renamed operator to a mul, a read to read, who takes a bogon and a float. And I'm like, no, you should take a ... and a float, not a bogon. So I don't believe my current typing is correct. And I'm sorting that out.
The correct type above this, above the incorrect type?
And what I put in for the correct type is the type I actually want. And the reason I put it that way is because sometimes with these examples, I discover that the type that I want and the type that I got, I'm confused about the actual type of what the expression should be, the type I think it should be. So it's a common situation where I am confused as to what type I ought to get, and the bogon is correct. Here I've got the bogon in reverse order because it's alpha sorting the fields. So let me make that maybe a little easier. So this is what, what I got is above, what I'm hoping, or sorry, what I want is above, what I got is below. And replace type I think with type I want. And then later along, sometimes I figure out, oops, you can't get that type. And in fact, what you got is correct. And sometimes it's neither of the above. And the correct answer is in between the two. So this is welcome to the land of Cliff trying to do typing empirically. I do massive counts of trial and error until I beat my head against counterexamples that defeat each other long enough to understand the root cause of the problem. And then I get it now. And then I go in and I fix it the correct way. And suddenly things all clean up and look good. But there are a lot of these examples where I think it ought to do this and I'm getting that. And which one's right, which one's wrong? And why do I think this? And why do I think that? So I have a much simpler example. It's producing the fake float fail at the bottom there. That actually I've gotten rid of overloads. But to get overloads in the first place, I changed a bunch of things. So I might have broken something, jamming overloads in. And even with them taken out of the example, they're in the code base. So I check for overloads and I do things, and some of those checks happen in different places and moved around, and so it could be that I broke it. So I don't need overloads to get a funny answer out here, and I'm unclear that this answer is, answer I got is correct. So I'm like, all right, we gotta go debug. Why did I get this? Do I believe it? Is it really there? It's clear that I passed the bogon field along. But if I pass a field along as an argument to a function and I don't use it, as far as I know, the function type should say it's a, there's probably.
So here the y.
I wonder when I make a fresh copy of fake float, if I need to do a ... Where the hell am I picking up? I'll not debug this live. It would be very tedious and slow, and I won't make any progress.
It should somehow, when you select from the Y, somehow restrict, somehow get rid of all of the feeds.
It has to pick up the float for sure. The other fields are not necessary. So,
but if you're copying, then you somehow have to tell it to get rid of all
when I unify the result of the f wrapped of the thing you've highlighted y.f with the argument that I've passed. I should drop the bogon field.
Yeah.
And I totally have code in there that at places he says, oh, you're unifying these two guys, and one of them's open and can take extra fields, and the other one's closed. The closed guy has to drop fields from the open guy can take fields from the closed, blah, blah. They do a thing,
Yes.
and you get a constraint. You get a
Yeah.
restricted set. Suddenly the bogon drops. Okay, that's been working. Overloads came along and did all kind of weird shit to me. And so somewhere in there, I probably blew this, and I'm picking up the bogon field, and I should have instead said, the guy on the left says he's closed, can't take your extra fields. The guy on the right has bogon. The result drops it. And that's the kind of thing that goes on there.
My hunch would be how the overload is selected. So you have to be sure that it's selecting, you think it's selecting
Well,
for the overloads.
Hang on. So I ditched the overload in my test case.
Mm-hmm.
The code is, I've restructured my inner unify code to handle overloads. So the unify code all changed. Like if I go backwards, like a week ago, this is a good point. If I roll backwards a week ago and take my example with no overloads, I'll bet you I don't get a bogon field out. I bet you as part of inserting the overloads, I screwed up the field unification story, and suddenly I'm picking up the bogon and I should have dropped it. And I'll bet you it's just a bug at the insert. Like I'm getting the code at the bottom with an example that has no overloads. So you're not seeing the smaller, the shrinkified example. I've way shrinkified the example. Fine. But I now believe that, if I go back a month and I still get the bogon, then I have to think that I'm like screwing up big time, or I don't understand the correctness here.
Yeah.
But I could like save everything off in GitHub and roll back to master of a week ago.
Just to make sure.
Just to make sure, yeah. And then pull this example out and say, what do I think this guy does? And the answer I'll bet you is that bogon goes away, and then I'll come along and say, okay, when I inserted overloads, I blew that.
Yeah.
Fine.
So there is no too much, because when you introduce all overloads, then you have to try several things, and you have to make sure that you are selecting the correct overload.
There was a lot of fun code involved. It wasn't gruesome. Like I said, I've been flipping experimentally on this stuff so long that I have a lot of infrastructure for adding new typing games. But there was a bunch of, no, I'm looking backwards at my old putbacks. There were a bunch of go-arounds on a bunch of places. Yeah, okay, I'll restate. Where did the first overloads showed up? Oh, gosh. Yeah, okay, so it's been a month and 20 commits. So yes, okay, never mind. I touched a lot of things.
You'll have to work.
I was hoping the core algorithm isn't really changed hugely. It says is over as the is overload question a couple times in the main unify, and then it runs off to the here's my overload thing. Yeah. But it got subtle, obviously, as these things do, as to when you call out and what you do when you get there. And the is over guy started doing a bunch of clever, careful things.
Yeah, you will figure it out.
Yeah, and I'm wondering now. I'll look at it. I'll figure it out. Yeah. So that's anyhow. This is what I'm fighting with at the moment. I had to make this last go round of changes in the core thing because I'd found another overload thing I hadn't thought my way through all the way that I had to sort out, that I got while I was in Philadelphia, except I spent most of my time with my 2-year-old granddaughter, so I didn't actually make much progress other than to narrow down the test case. And then a big whack when I got back, and then I got sick, and then I got I'm like, you all know what goes on there.
Yeah.
A little more yak shaving, a little more yak shaving, a little more yak shaving. All right, well, we're heading on 2 hours, and I've been yakking AA typing games, which is fun for me to talk about, but that's all good.
It's fun.
All right, good. It's actually fun for me too. Like things I can discover that I can type successfully. Always kind of, eyeball pops open. Wow, that type just straight up like the Y Combinator. I think Alan asked for the Y Combinator some month ago or whatever, and I just, yeah, that's a good answer. And I threw it in, and it just typed. It was good.
Yeah.
All right. Well, then I'm going to declare victory for the Alliance and stop talking.
Okay.
Yeah. And I'm going to find out next week what happened to Cameron, who texted me. I'll let him say. It was pretty funny, though. He had some funny. So something happened with Cameron would be fun to hear what's going on, too. And the XKC.
So what is your next thing after it looks like typing is stable? Do you head off to code generation or?
Oh, once typing is stable, I move it over to the main code base and get it stable there. Then I get a REPL that I can type expressions arbitrarily in. And so that would be when typing settles out. When typing has
so you think you'll
out,
do a you
yeah,
think you will do a
execution after
REPL
that.
before you actually do something that does code generation?
I'll do some execution strategy, the cheapest possible, quickest execution strategy that I can get my hands on, so that you can play with the language and decide that you hate or love things. So that will almost surely turn into like cough up Java bytecodes as Java assist as the cheapest possible way to make forward progress. Not that I'm intending to have a Java backend underneath me all the time, and that's fine. But the fastest way I can get something that'll run, since I'm already coded up in Java, I'll just cough up Java bytecodes.
Because I know you've had the discussion several times of whether to do an interpreter or a level 0 JIT that just sort of templates out everything.
Right. When I get away from backing a Java, a VM backing, then I'll have to make that call between an interpreter and a level 0 JIT, template JIT. I know how to cross call between them now. It was a painful experience in the land of Java. There are some stupid subtleties that we're now well aware of. So, it's not the end of the world to live with an interpreter. It's also not the end of the world to live with a template JIT. There's another version of that which says I'll make an interpreter which uses a fixed frame. That's probably what I'll do. I'll use an interpreter instead of a template JIT, but the interpreter will use a fixed size frame so callers can call it like it's a fixed size frame calling convention, like every JIT call calling any other JIT call does. You ask the call target what his frame layout is by asking what his signature is and his calling style. He's native call, foreign function. He's Java to Java. He's Java to interpreter. He's Java to C or whatever. And you get his frame layout. Then you JIT a call to that frame layout. The problem with calling the interpreter was that the frame layout changed as the interpreter executed because he does a stack thing. And so at any given moment, his stack frame is variant size and variant offsets and variant layout. And that was the pain in the butt. So a fixed frame interpreter.
That does seem avoidable if you know to avoid it.
Yeah, right. Fixed frame interpreter should not be too hard to do. Probably what I'll do is I'll register allocate on an infinite register set of stack slots for the variables in your expression. And the interpreter might choose to hoist the top of stack one into a register, as an optimization, but he'll not maintain an actual stack. And the bytecodes won't be stack bytecodes; they'll be register to register bytecodes. That'll be the current operating theory. There are other bytecodes that are in between stack and register register that give you the benefit of register register without they're not as fat as the normal 3 address register. There's things you can do there. It's not a big deal. That's not where your time goes or your space goes, so maybe I don't care. All right, yes. And if you ever feel like you want to burn your brains out on typing theory, you are totally welcome to pile in on what the hell goes on in a typing game here. Even if it's just like up on Discord or not Slack, Discord, talking types just to help me sort out or help you sort out I'm all happy to bounce these things off people's heads because I don't necessarily get it right the first time, and talking to another person helps. All right. I'm going to stop screen share, declare victory, and see people next week. Yeah, should be on good. What are we up to here? We are, what day is the 12th? We're on next week. The week following is Burning Man. And there's a reasonable chance that I'm in for 2 weeks of Burning Man. So it might be a while because of Burning Man. We're on this year. It's been a while. I'm looking forward to it. We're doing burner stuff yesterday and probably again today. You know, all your infrastructure you need to go live in a completely flat, empty desert land for 2 weeks. A bunch of stuff. All right, till we meet again.
Okay, bye.
Bye.